So there are two R formula to convert. So the first R formula is the one for sine. So R formula for sine function. So I'm going to call this the sine formula for uh, uh, the R formula for sine function. So when do you use the R formula for sine function? You use it when sine x comes first. You use it when sine x comes first, then cosine x. Okay, so if you want to use the R formula for sine function, you use it when sine x comes first. So the other one, you use the R formula for cosine function when cosine x comes first. I think that's quite easy to remember. So if cosine comes first, you use the R formula for cosine. If sine comes first, you use the R formula for sine function. Okay, so if you realize that part of the formula is it involves the A and B. So the A and B is the coefficient. It is the coefficient E regardless of the sign. Okay, which means right, it doesn't care whether it's positive or negative. Okay, we just take the the actual numerical value. Okay, so if for the R formula for sine function, the sign will follow. If this is plus minus, this will be plus minus. So for the R formula for sine function, it will follow the sign. Plus follow with plus, negative follow with negative. So to execute the formula, you need the value of A and B. So you must be able to detect A and B first. So in my example here, this will be my A, and then this will be my B. So E regardless of the sign, you don't have to care about the minus. Okay, so you don't have to care about the minus. Okay, you just take the A and B. So once you got the A and B, you can directly plug into this formula. This formula, some people feel that it looks a bit like Pythagoras. So you can use the idea that it looks like Pythagoras to help you. Okay, and then you use another, with your A and B, you can easily put it into the alpha formula. So this alpha formula is not exactly the basic angle. So don't get confused. This is the alpha for R formula. It's not the basic angle. So you put your A and B, and then you do a tangent inverse. So from here to here, you just press the tangent inverse. You will get the alpha. Okay, so that is once you successfully get your A and B, plug it into the two formula, plug it into these two formula, you will have successfully convert already. So my R here is root 11. My alpha is 25.2. So you just simply get the R, get the alpha, then you will have used the formula. You will have successfully used the R formula, and you already convert sine and cosine into a sine function. So you observe here, you got a sine function, you got a cosine function. After you use the formula, it's only cosine left. It's only sine function left. So we already successfully convert two trigo into a single trigo. So this is the easiest way to do. But some schools or some of you, your teacher may go through the derivation. They may make you present the derivation. So this part, I'm going to be explaining. If your teacher, if you are the one where your teacher actually go through this method too, then during exam, you got to present method 2. So to do method 2, okay, we just, it came from an addition formula. So we are going to convert this into the sine R formula for sine function. So what do you do? What do we mean by we are using addition formula? So this part looks like the sine A minus B formula. So this part looks like the sine A minus B formula. We should learn it in the addition formula. Sine, cos, sine. So I'm applying this. So sine, cos. So I'm doing the sine, cos, sine. But my A here is x. And my B is alpha. So I apply the addition formula. So after I apply the addition formula, I'm supposed to expand out. As I expand out, there's a part. This will be grouped with this to become the coefficient of sine x. So you go and expand out the square bracket. So when you expand out, right, the r and sine alpha become the coefficient of cosine x. So after you use your addition formula, you need to see that this is the coefficient of sine x, this is the coefficient of cosine x. And then we are going to do the comparison. We are going to compare. So if you compare sine x with the sine x here, you will realize that this is a 3. You compare the sine x on the left, you compare the sine x on the right. You will be getting r cosine alpha equal to 3. Okay, so I am comparing the sine x on both sides. Okay, so in case you couldn't see, if you find it a bit difficult to see, right? Okay, you can actually do it something like this. So if you got difficulty comparing, you can put it like this. So if you put it like this, I think it might be easier to see that this is equal to 3. And then this is equal to root 2. Okay, so you apply the addition formula. So after you apply the addition formula, expand, and then you find yourself grouping r and cosine alpha. So r and cosine alpha is the coefficient of sine x. So now you can put it in this way for comparison. So that's how I get my equation 1 and equation 2. So from the addition formula, you do a comparison of sine x, you do a comparison of cosine x. So that's how you get equation 1 and equation 2. And we're going to square them to add them up. So we're going to square equation 1. We're going to square equation 2 and add them up. There's a reason why we want to square it. Because when I square it, right, I get something like cosine square plus alpha square. Cosine square plus sine square, that's what I meant. Cosine square plus sine square has a value of 1. Okay, so we square the left side, we square the right side, and we square everything. So when we say 1 square, right, means you just square this, you just square this, and you just square this. When we say equation 2 square, you are also squaring this, and squaring this. You add the left, you add the right. So when you do that, eventually you realize you got the same r value. R is equal to root 11. Previously, I'm also getting r equal to root 11. So you may be thinking, method 1 looks easier. Why am I using method 2? So method 2 is actually the method 1 actually came from method 2. So it's just that they skip the derivation. So some of you, right, your teacher will show you method 1, use the formula direct. Some of you, your teacher will show you method 2. Okay, so after I get my 2 equation, I will So after I get the 2 equation, these are the 2 things I will do. So I will do a 1 square plus 2 square. And then the second thing is I will take the second equation, divide by the first equation. Because when I do that, I will get a tangent. So I do a left side divide by left side, right side divide by right side. So I still get the same answer as my method 1. So I still get the same conclusion. So I will be doing these 2 standard steps. So I'm still getting the same answer. So I use my addition formula. I compare the sine x, I compare the cosine x. And from the comparison, I can do the one's equation square. I can do this part to get my R and get my alpha. Okay, it doesn't change the answer. You will still get the same answer as method 1. So method 1 is without derivation. Method 2 is using the derivation from addition formula. So the same thing is going to happen for cosine, R formula for cosine function. So R formula for cosine function, I still need my A and B. I need my A and B so that I can execute this formula, So for this question, the A and B is very easy to tell. A is 8, B is 2. So cosine come first, you're going to use the R formula for cosine. But the trick about this cosine thing is if this is a plus, it will be a minus. If this is a minus, it will be a plus. So it actually follow the addition formula for cosine, which we can see in second method. So anyway, method 1, we just get our A and B. Our A and B will allow us to use this formula and we get our R. Our A and B also allow us to use this formula and I can get the alpha. And straight away, I will get the conversion already. So method 1 is very direct. Get your A and B, plug into the formula for R, plug into the formula for alpha. So for the derivation part, I will be using, in this case, I'm using cosine A plus B. So if you still remember, cosine A plus B is cos, but it's a minus. So I use the cosine A plus B formula. Okay, I expand it out. This and this will become the coefficient. It will be the coefficient of cosine x. And when you expand out, R and sine alpha will become the coefficient of sine x. So again, I gotta be comparing my cosine and comparing my sine. So in any case, if let's say you have difficulty comparing, you can put it this way. So if you got difficulty comparing, right? Okay, you put it, you stack it up. So you stack it up, you compare on the left side. So if you do the comparison, right, it will be easier. You will see that this is equal to 8. If you compare the cosine, you will see that this is equal to 2 when you compare the sine x. So that's exactly what I'm comparing. So when I do the comparing successfully, I would have gotten this and this. So again, I'm making use of the formula sine square plus cosine square. So I'm going to square and add up the two equations. So I square and add up the two equations, and I will get, okay, I think I wrote something wrongly. This part should be alpha. So from here, I still get the same answer for R. So I get my R is root 68. So after that, I'm still doing the second equation, divide by first equation. So when I do that, I get a tangent. And I get my alpha. So I'm getting the same R and the same alpha. Method 1 and method 2. It shouldn't give you a different value of R and alpha. So it's a method, it's just that method 1 has no derivation. We go direct. Method 2, the derivation comes from addition formula. Okay, so there are two R formula, one for the sine function, one for the cosine function. So you got two methods to convert, method 1 or method 2.